All right, next measure, we call it mode. Let's check the definition. The mode of data set is the value or values that with the greatest frequency. So here it's possible to get more than one mode. So the properties of mode, the mode can be found with qualitative data. But for the previous two, mean and median, only can be found with quantitative data. But mode can be found qualitative data and quantitative data. And for the second property, we know it's possible to be no mode, one mode, or more than one mode. Let's check how to find the mode. So, and what is called the bimodal. So if we just have two data occur with the same greatest frequency, so that means we will have two modes for the data set. Then we call this data set is bimodal. But if we have more than two, let's say 3 or 4 values occur with the same greatest frequency, then we have 3 or 4 modes for the data set. We call this kind of data set mod model. So this is not hard to understand, right? If we have 2, we call bi. If we have more than 2, we have multi. So here, if it's no mode, then every value is not repeated. So there is no mode. We can check some examples to help us understand. Try to find the mode. So first, we can check all the values here and try to find which one occurs the most frequency. We will find 0.2 occurs 1 time, 0.3 3 times, 0.6 2 times, 1.2 1 time. So it's very clear, right? The 0.3 occurs the most because we have 3 0.3. So 3 times is the most frequency here. 0.3 is our mode. Now we try to check this group of values. This time we have 0.3 twice, 0.6 1 time, 4.0 twice. Then both 0.3 and 4.0 occur twice. So both 0.3 and 4.0 are our modes. So this is bimodal, right? Let's check another example. So this time we focus on these values. We have 1 0.3, 1 1.1, 1 2.41, 4.0, and 1 5.0. No value has been repeated. So we have no mode. So it's possible to have no mode, 2 modes, or 3 modes, or just 1 mode. Okay, next one is called midrange. The midrange is just use 2 values. It's just measure the center, or we call it's just the midway between 2 values, minimum and maximum. We just pick 2 values out, the largest number and the smallest number, then try to get to the midway. So how can we get midrange? We only need maximum value plus minimum value, then divided by 2. This is called midrange. This measure only use two values of a whole data set? Because it just uses two values, it's very sensitive. Very, very sensitive. So it's called very not resistant, right? Not resistant. Sensitive, not resistant. Not sensitive, it's resistant. Because if we add some extreme value, then that extreme value will be either our minimum value or our maximum value. So that means the mid-range will dramatically be changed. So it's not resistant. And because we just use two values of the whole data set, lots of information is missing. But why we still need to learn it? Because it's easy to get. It's very easy to get. Sometimes we cannot get the whole data set and we just get very limited information of the data set. Maybe we just know the minimum value, the maximum value. Then the only measure of center we can get is just the mid-range. So, and it's very easy to compute. Okay. So that's the reason we still need to learn how to get the mid-range. But it's sometimes the mid-range don't get confused about mid-range and the median. Okay, median is just which value or which two value right in the middle of the whole data set. But the mid-range just pick the large number and the small number, then get the mean of these two numbers. Okay, that's a big difference. We still do the practice. Okay, try to find the mid-range. Okay, we only pick the minimum and then the maximum. So the maximum will be this, and the minimum will be this. We only use two values. Then try to get the mean of these two values. So add them up, divided by 2. This is how we get mid-range. Okay, now we talk about the round-off rule of the measures of center. Basically, median, mean, and mid-range, we should carry one more decimal places than the original data value. So if the original data value is a whole number, then for our mean, median, mid-range, we should keep one decimal place. So if the original data values has one decimal place, then we should keep 2 for our measure. But for mode, we just without rounding, we just leave the value as, just keep the same as the original data value. So if the original data value is a whole number, our mode is also a whole number. But for the median, mean, or mid-range, if you forget the round-off rule, always keep 2 decimal places will be fine to me. Okay? Always keep 2 decimal places. Alright, so we can quickly skip this. Let's check this one. Some examples. Let's see if they are meaningful statistics. So first example is the zip codes. Is that meaningful if we get the mean value or median value or something like that? I think you already get the answer. Definitely no, because they do not have quantitative meaning, right? Doesn't measure anything or count anything. They are just some labels. So this kind of values is not meaningful to get the measures of center. And the rank. And the rank is also not meaningful to get the measures of center. They just show you the order, doesn't count anything. Okay, sometimes we should get the mean from a frequency distribution. If we do not have the original data set, we are only given a frequency table. We could use this formula to get the mean value. But this mean is not the exactly mean. It's just the mean from a frequency distribution. So let's check. Here, x is not the single x value because we do not have single x value, right? So it is just the class midpoint. It's just the class midpoint. And f here is just the frequency. So we check this formula. We should get the product of each class midpoint and the frequency. So if we have 5 class, we get 5 product first. Then we do the addition. Get the sum of 5 products. Then divided by the total frequency. Total frequency will be just the number of values. It's equal to n, right? So the total frequency is just n. But make sure you know here, this x is not individual x value. It's just the class midpoint. And the result is not the same one as the accurate x bar, because we only have the frequency table. When we cannot get the exactly data values, we pick this way. If we can get the data values, of course we choose the exactly x bar. So this just show you the example. How can we get the x bar from a frequency table? Okay, just like I said, first we should get the product of frequency times midpoint. So first we do the multiplication. After that we do the addition. Okay, make sure you understand the formula well. First do the multiplication, then get the sum of 5 products, then divided by the n or the sigma f. They're just the same thing. So this is just tell you when we cannot get all the data values, we should pick this way. So this is how we get it. This is the sum of 5 products, then divided by the total number n. Okay. So the last important one is called weighted mean. When different value x assigned different weights w, we cannot use the regular x bar formula to get the mean. We should get a weighted mean because different x value here has different weight. So what does this mean? Let's check the example to help you understand. So let's check this student. Her final grade has A, but this is 3 credits course. Another A for 4 credits course, and B 3 credits, C 3 credits, and F. She got an F, but this F is just 1 credit. So we can see different course has different credit, which means different grade has different weights, right? Different credits means different weights. And here we have different values, but the value is just the letter grade. It's just the letter grade. We cannot get the mean by using the letter grade. So first step, we should transfer the letter into the values. So we use this rule. A equals 4, B equals 3, and so on. C equal 2, D equal 1, F equal 0. Now we can use these values. This will be our x values. This letter grade, we transfer the letter grade to the numbers, and these are our x values. X values. Okay, this will be our x values. And we should know different grade has different weights, right? We use their credits as weights. Credits as weights. If this course is 3 credits, we put 3 as its weight. And we also replace A, B, C, F with 4, 2, 1, 3, 2, 0. And letter transfer to the number, and they are x values. And the credit is our mates, our weights. Make sure don't mess them up. Now we can use the formula. So this is the 3 credit course with an A. And the second one will be the 4 credits course with an A. And this will be 3 credits course with a B. And 3 credits course with a C. And 1 credit course with an F. We get the product first, then add up all the products divided by the sum of all the weights. 3 credits, 4 credits, 3 credits, 3 credits, 1 credit. Okay, so total we will get this 3.07, and this one is called weighted mean. Different x value has different weights. Okay, so if we use the round-off rule, because original data is whole number, because we transfer A as 4 points, B as 3 points, but here we still keep 2 decimal places. Okay, and I think make sure do the practice for the weighted mean, because this will be the most difficult part in the whole section. Okay, and all the PowerPoints can be found in the contact in your Blackboard. I suggest you can print out all the PowerPoints, and when you check the video, you can use the print out PowerPoints to do to take the notes. Again, you can find the PowerPoints in the content of your Blackboard. And always check your homework from the announcement. Okay? Thank you.